I want to hit table of values kind of quickly, and then we will move on to 4.02. Also, Cheyenne, you sent me an email yesterday. I haven't got a chance to look at the problem yet, but hopefully I will tonight, and I will I'll send you what you asked for. So okay, table of values. Table of values, if you'll remember, looks like this. It is just a little table that we can draw, and we put our X over here and our Y over here, and we put things that we're going to plug in. So I like -1, 0, and 1. So usually they give us an equation to go with this. So the equation could be y equals -3x plus 1. And y equals -3x plus 1. And the way that we use our table of values is we plug each of these numbers in for x. We say, okay, our x is each of these, and we do these individually. So first we're going to do -1. Y equals -3 times -1 plus 1. And then we work that out. So we multiply our -3 and our -1. We're going to get positive 4 equals y. So now right here, I'm going to put my 4. So this gives us useful points when we go to graph this equation. Later on, we're going to learn a few more efficient ways to graph equations, but for right now, this will work most of the time. It's not the best way, but graphing equations will work by just plugging in values a lot of the time. So if we're trying to graph this, our first point is -1, 4. So now if we plug in 0, we are going to get 0 plus 1, 1 equals y. So we get 1 there. And then we plug in 1. So 1, -3, because -3 times 1, and it's going to give us -2. Okay, so when we go to draw this, I'm going to put my y-axis right here and my x-axis right here. So -1, 1, 2, 3, 4. Because remember, when we're plotting these points, we're plotting x, which is left and right, and then y, which is up and down. So now we are plotting 0, 1. So left and right, 0, up 1. So right here. And then 1, -2. So over 1, down 2. So we put it right here. And now we draw a line through these guys. My lines aren't great, but there we go. So that's what our line's going to look like, and it should pass through all 3 of them. Anything that we plug in should be on this line. So if we plug in 1/2 or 9 or 45,000, it should be on this line at some point. So table of values is just a useful way that we can find domain and range values. And if you'll remember, our x is our domain. This is all of our domain values, and this is all of our range values. And our domain is, if you think of it like a factory, our domain is the raw materials that you put in. So it's what you put into the factory. And then the range is what you get out of the factory. So we're plugging in -1 into our factory. Say this is plastic, and we get out water bottles. So we plug in -1 and we get out 4. And this is the actual factory that we're talking about. It's the equation. So we are running -1 through the factory, and we're getting out 4. So that's kind of how the relationship between the domain and the range works. I know that we've gone over some of this before, but I know that we've been moving kind of fast, so I kind of want to hit it again, so that way you guys can be sure to feel confident about it. So we'll do one more table of values, and then we'll move on to slope. It's looking like it's going to be a pretty short lesson today. So if we did y equals 4x, and we want a table of values here. Sometimes it will go ahead and it will give you your values. So it'll say x and y, and it'll give you 2, 4, and 6, or something. So if it doesn't give you anything, you can choose. And what I encourage you to choose is -1, 0, and 1. But you really can choose any numbers, but sometimes it'll give you stuff, and that's okay. You just have to plug it in their way. So this is our domain if it asks you to identify it, and this is going to be our range. We haven't found it yet. So our function here is y equals 4x. So y equals 2. I'm plugging in my first value. 4 times 2. And we're going to get 8 out. So now we plug in 4. And 4 comes from right here. So we're going to get 16. And now we plug in 6. And we're going to get 24. Now, if it asks you to graph this is going to be kind of difficult unless you have a huge graph. So that's another reason that it's useful to choose smaller numbers that are centered around 0, because most of the time they're going to be pretty easy to graph. So you could still graph this if you wanted to. It would just be a bigger graph. But there's nothing wrong with doing it this way. Just the numbers are bigger. Okay. One other thing with table of values is sometimes it will give you an equation and ask you if a certain thing is a solution. So if it gives you y equals 4x, like we just had, and it asks you, okay, are 5 and 10, is this a solution? And you say, okay, well, this isn't like a table of values problem that we've done. And really it is, but what it's asking you to do is this. Do your table of values. It asks you to plug in 5. And it says, okay, will you get 10 out? So it's saying what you get here, does it match this? And if the answer is yes, then yes, this is a solution. And if it doesn't, then no, it's not. So we plug in. We say 5 times 4. And we're going to get 20 right there. So 20 and 10 don't match. So this is not right. This is not a solution. So maybe it gives you 4 and 24. So we can plug in. 5 and 24. And it asks us to find what is our second value. So we plug in and we're going to get 16. So again, not a solution. So all it's going to give you is this right here. Your problem will look like this. And it will say, is this a solution to this equation? And what you need to know to do is plug this into the equation and see if you get this. So let's try one that is a little more complicated, and then we will move on. 2x minus 4y equals 5. Okay, so this looks a little different. We don't have y by itself, and having y by itself is a very helpful thing to have. So the first thing I'm going to do is move my equation around and get y on the side by itself. And what I'm going to do is I'm going to move my 2 to the other side because we want everything away from y. We're just trying to get y by itself. So I'm taking my 2x away from this side. So I'm going to be left with -4y equals 5 minus 2x. We're okay so far, but y is still not by itself. Y still has a -4 with it. So I'm going to divide by -4. These are going to cancel. We're going to end up with y equals 5 minus 2x over -4. So now we have an equation where y is by itself, which is what we want to work with for table of values. So, and you can also do this way. You're going to see this a little later. Instead of dividing everything all together by 4, you can do it like this and just divide each thing by -4. It works out to be the same way. I'm just going to leave it with one big fraction for right now, but that either one is perfectly fine. So now that we have this, it wants us to check if 1, 3 is a solution. It wants to know, okay, does 1, 3 work for this? And we say, well, we don't know yet. What we have to do is we have to plug in our 2 for x. So I'm going to do 5 minus 2, or we're plugging in our 1 for x, I'm sorry. So all I did was put that in there. So now we work this down. We do multiplication first because of our PEMDAS. So parentheses, exponents, multiplication. Well, all our parentheses are doing here is just multiplying. So when we multiply, we're going to get 5 minus 2 over 4. So now we do division, which we really can't do quite yet. So what I'm going to do is get this top simplified as far down as I can where it can be one number, and then I'm going to divide it. So 5 minus 2 is going to give us 3. So we're left with 3 over 4. So now we have 3 over 4 equals y. I just didn't write it here, but it is still there. So we know that this is not a solution because when we plug in 1, we get 3/4. Does this make sense? Okay, so let's move on to slope. Slope is when you have a graph, the slope generally tells you how far up and down and left and right that the points will be. So it tells you how the line will look. So if we have a line that looks like this, and we want to figure out the slope, what we do is we take the rise. So we go up from a point, any point, and usually you're going to want to pick like one of the crosses on the graph. So let me actually redraw this line a little bit so that way it comes out a little neater. Okay, let's do this one. So we pick a point on the graph, any point, and we say, okay, how far does it go up before we can go to another point? Well, right there, because we're trying to aim for this point. So then we go over, and we count how far we went up, 1, and how far we went over, 1. So our slope is always rise over run. So we rose 1, and we ran 1. So when this breaks down, it's a fraction. When it breaks down, it's going to be 1. So our slope of this line is 1. Well, sometimes it's not as simple as that. Sometimes it's not just a whole number, or sometimes it's not just 1. So if we do this. Now we're going to do the same thing. We're going to pick a point on the line, any point. I'm going to take this one. And I'm looking for somewhere that it crosses at whole numbers. So I'm looking for something on this line, something on this line, something like that, something on a line. So now we go up until we find another point. So it looks like this is our next point. So I'm going to go up. And I rose, it looks like 3 points. And then we go over. We say, okay, here's another point. And we went over 2. So now we're looking for rise and then run. So we went up 3 and then right 2. So this is our slope of this line. So finding a slope is usually just as simple as plugging in and going up, going over, and finding that. So maybe sometimes we'll have a line that's not looking like that. Maybe it looks like this. Now we go, I'm going to pick a point. I like picking points up at the top. So I'm going to pick this point. And I'm going to pick another point that crosses, so maybe here. I'm going to go over and then down. I'm just going to make a little triangle. And now I'm going to count. So I went over 3 and down 1, 2, 3, 4, 5. So since we went down, it's negative. So our rise is now -5 because that's how far we went up and down. It doesn't always have to go up for it to be a rise. We can rise downward. And then we run 3 because that's how far left and right we went. So finding the slope of when it gives you a graph is just as simple as counting like that. Finding the slope if it gives you something else is not always that simple. So if it gives you a table of values, if it says so 1, -6, 4, -8, 7, -10. So there is something we need to use here to find the slope, and that is the slope formula. And the slope formula is this. And our x's and our y's here, they represent some of these values. So what we do is we pick 2 points, any 2 points, it doesn't matter. So I'm going to take these guys, and I'm going to write them down here like this. X, Y, 1, 2. 4, -8, 7, -10. And so with this, we can use this to find what our x1 and our y1 and all that is. So if we just look for our y2, for example, we just go to y, then we go to 2, and we found it. So -10 minus y1. So y and then 1, -8. x2 minus x1. And now we work this out. So negative 10 minus minus, which two negatives make a positive. So we have negative 10 plus 8 is going to give us negative 2. 7 minus 4 is going to give us 3. So now we have a slope of negative 2/3. And we could do this with these 2 points, and it would work the same, or we could do it with these 2 points. It doesn't matter which two you choose, just as long as you write them in a table that looks like this, and then use that for your slope formula. And it's going to give you the right slope every time. So, here is an example from your work. It's number 12. I'm going to screenshot it and put it on the screen. Okay. So Michael has started a savings account with $300. After 4 weeks, he has $380, and after 9 weeks, he has $620. What is the rate of change of Michael's savings account? And the rate of change is the slope. I know we covered it earlier with, we covered it in its own section, but the rate of change is usually called just the slope. So what it wants us to do is write it in ordered pairs. So we're going to work on this first step first. And I'm going to kind of use the table of values idea that we've been using and go from table of values into ordered pairs. So we say, okay, Michael's starting a savings account with $300. So when he first starts, he doesn't have any money at all, or he doesn't have, no time has passed. So at 0 weeks, Michael has $300. And then we say, okay, well, after 4 weeks, Michael has $380. So 4, 380. And then after 9 weeks, he has 620. So we could use any of these three ordered pairs. We could write them out as 0, 300. That's how an ordered pair is written. 4, 380. 9, 620. Once we have these guys, then we can use whatever we want for these. So now we need to find our slope. So this is y2 minus y1, x2 minus x1. Just to remember, y2 minus y1, x2 minus x1. I'm going to use these top two numbers here. And I am just going to, actually, what I'm going to do is use these two. I'm going to use the bottom two. So we do x, y, 1, 2. And we draw our little grid. And we say, okay, 9, 620, 4, 380. So now we look and we plug into our slope formula. So y2 is 620 minus y1, which is 380, over x2, which is 9, minus x1, which is 4. So 620 minus 380, 240, over 5. 240 divided by 5 is going to give us 48. So our slope is going to be 48 over 1, or 240 over 5. Either one. This is the simpler way to write it, but 240 over 5 isn't wrong. So this just goes here, and then you can just write 48 here, because anything divided by 1 is itself. So 48 over 1. And then we say, what is the rate of change of Michael's savings account? 48. So that's how you solve problems that look like that. Okay, so one last type of problem that it will give you in this is it says, okay, we have a problem with a slope of, or with a that looks like that. And then we have a line through the point to 1, 4, 2, and 6, 3. And what it wants to know is which of these has the largest slope. And the largest slope means that it is the biggest, like this. That this is the larger slope from this one. And then if we had this one, this is the larger slope. We had this one, larger slope. So the further it gets to vertical, the larger it's going to be. That also works with numbers. As the number gets bigger, the larger the slope. So what we need to do is we need to find our slope from here. So I'm going to do that using a table of values. I'm going to do x, I'm going to do y. I'm going to plug in 0 and 1 because I only need 2 points. So I plug in 0, I'm going to get 0. I plug in 1 and I'm going to get 3. So now I'm just going to kind of write this as my table. So now I'm going to plug the slope formula in right here, which is y2 minus y1 over x2 minus x1. So when we plug this in, we're going to get 3 minus 0 over 1 minus 0, which is going to give us 3 over 1, or 3. So we have a slope of 3 for this one. Now over here, we need to do the same thing. So I'm going to use 2, 1, and 4, 2. xy, 1, 2. So now I am going to plug into my slope formula. y2, 2 minus 1, y2 minus y1, 4 minus 2, x2, x1. So we end up with 1 over 2. So between these, which one is the larger one? Well, the larger number is the larger one. So 3 is going to be the larger one. So we did this just by finding points that we could plug into the slope formula. The slope formula is going to be your best friend when it comes to finding slope, and it works in a lot of cases. So use it, and it's very helpful. So that is the end of the week's work. So I'm gonna let you guys go early today. Y'all have a great day, and we're also not going to have a class on Friday. So don't bother joining the meeting or whatever. I'm not gonna be here. So I will see you guys on Monday, and have a great weekend, guys.
Bye, Mr. Albright.
Bye.
Mr. Albright. You mind?
Have a good day, guys.